Hello, students, and welcome to the review for Unit 2 of Geometry A called Logic. Now, you may have heard of logic before, but probably not in the way we're using it in geometry. There's a lot of vocabulary included in this unit, and some of it you will need to know for the unit test. So I've tried to pick out just those things that you most need to know for the test. So let's get started. First of all, some principles of logic, and of course, some vocabulary. Conjunctions are always seen with the word and. So if you have two sets or two statements, they both have to be true. And when you see the upside down U or upside down V, that means and. That's a conjunction. Both things have to be true for these conjunction statements to be true. On the other hand, a disjunction is used with the right side up V. This means that P or Q, the statements P or statement Q, either one can be true for the whole disjunction to be true. When you're looking at a negation, use this little squiggly line in front of the statement that you're talking about. So that means not P. If I say the sky is blue, then not P is the sky is not blue. Now, we talked about conditionals, and they are expressed with an arrow. P implies Q. So it could be written as Q provided P as well, and you'll see a question in your test that actually has that designation, but it's usually read if P, then Q. Here's an example. If you're given the statement, if two angles add to 180 degrees, then they are supplementary, then you could write the converse, the inverse, or the contrapositive of that statement. Here's a little illustration so it shows what it's looked like. Here's two angles that add to 180. They are supplementary by definition. However, if you wanted to write the converse, then you are just going to switch the order of the two statements. There's an if statement, then a comma, then a then statement. So you're going to switch them around and put they are supplementary as the if statement. If two angles are supplementary, then they add to 180 degrees. So this is not always true. If one statement is true, the converse isn't always true, but in this case, they are. The inverse, on the other hand, is when you keep the same order, but you negate both the if and the then part of the sentence. So instead of if two angles add to 180 degrees, you say if two angles do not add to 180 degrees. And instead of then they are supplementary, you say then they are not supplementary. So keep the same order, just add the word not after the verb. The contrapositive combines these two. You are going to switch the order of the two phrases and you're going to add the word not. So if two angles are not supplementary, then they do not add to 180 degrees. Make sure that you have these in your notes because you will have to identify them in the test. Now, you were presented with a ton of truth tables. I don't think you're going to remember them all, but if you think about them hard enough, you will be able to recreate them, and hopefully you'll have a few in your notes. Here is a truth table for if P, then Q. If T is true and Q is true, then together they are true. If P is true and Q is false, then the truth of the whole conditional statement is false. If P is false and Q is true, then the whole statement is true. And if both of them are false, then it is also true. You'll notice that the only time the truth value is false is if the first statement is true and the second statement is false. Now, how could this be understood? Well, I always use the example that your mom comes in and she says, if you eat your vegetables, then you can have dessert. That's the promise, and that's the condition. So if you eat your vegetables, that's true, and you have dessert, then the whole promise or the condition was true. If you come in and eat your vegetables and she says, well, I changed my mind, you can't have dessert, that wasn't the deal. That was a false deal. She had promised you dessert if you ate your vegetables, and so the whole thing is false. And you can say, Mom, you lied to me. Now, on the other hand, if you don't eat your vegetables and she decides to give you dessert anyway, the condition is still true because she said, if you eat them. And so this isn't part of the deal. So that's still true. And then if you don't eat your vegetables and she doesn't give you dessert, that's still true because the deal was kept. So the only time the deal was really broken is if you decided, okay, I'm going to get dessert if I eat vegetables, so you eat the vegetables, but you don't get dessert. That is false. Okay, so here are some that will occur on your test. If P is false and Q is true, then P or Q is true because one of them is true. Remember, we talked about conjunctions. This is a disjunction. Only one of them has to be true. Here's another one. If P is true and Q is false, then if P then Q, like in this truth table, is false. That's the one where you eat your vegetables but don't get dessert. If P is true and not Q is false, then P not Q is false. Why? Because not Q is false means that Q was true. So that's true, true. And if it's changed, then it's false. It becomes this one right here. If P is true and Q is true, then not P implies not Q is true because that would mean it was false, false, and down here false, false is true. If P then Q is true, then P can be true or false. We don't know what the value of P is simply because it's in a conditional statement. Okay, now you learned the difference between inductive reasoning and deductive reasoning. We're going to be dealing mostly with deductive reasoning, but we used a lot of examples so that you can tell the difference between the two. Inductive reasoning is used when you're learning something. If you find a pattern and it seems like it's always happening the same way, then you're going to just assume that it's true. So here's a kind of a synopsis. Given several examples, you can draw a conclusion. So you visit a farm, you notice that white chickens lay white eggs and colored chickens lay brown eggs, so you decide only white chickens lay white eggs. You eat, and that's pretty valid. You eat at several Mexican restaurants and you decide that Mexican food is hot because every time you eat it, it's hot. Now that may or may not be true, but you can assume it's true if you're using inductive reasoning. Now deductive reasoning is a little bit different because it's based on a rule that you already know or you've already learned or you're already told. Given a theorem or a generalization or a rule, prove assumptions or conditional statements. If 60 seconds are 1 minute, because somebody taught you that, 60 minutes in an hour and 24 hours in a day, then 86,400 seconds are in a day. So you used what you had already been taught, what the rules already were to make a conclusion, and you did that deductively because it was based on the rules you learned. All professional athletes earn a lot of money. Wes plays professional football, so he makes a lot of money. So this is based on a rule that you already assumed was true. And so you can make the conclusion that he makes a lot of money. Now, it may seem like there's a fine difference between the two. So just keep in mind for inductive, you've got to have a bunch of examples first. For deductive, you've got to have a rule first. Either one can be true or false, but those are the different kinds of reasoning. Okay, we did start writing some proofs, and there's a specific format that we're using for proofs, and it follows this exact order every time. First of all, there's the statement of the theorem. if one angle of a triangle is 90 degrees, then the other two add to 90, because remember, we know that the internal angles of a triangle equal 180. Sometimes there's a figure, sometimes there is not, but if there is, it comes next, and you have a triangle that has a 90-degree angle. Finally, the given statement is one angle of a triangle is 90 degrees, and you can see that that's given because it comes after the if in the theorem. The to prove statement is the other two add to 90 degrees, and that comes after the then in this one. And sometimes in your lesson you'll see it just says to prove, so you know that that's the to prove statement. Now, finally, the plan of the proof is when you start writing the proof, and it's usually 2-column, although there's one incident where you can write it out as a paragraph. Then you put the steps of the proof, and you always set them up in this format with the given statement first, and then the reason for it in the second column. The reason for it is always given because it's the information given to you. Then you move step by step through the proof, saying, well, if that's true, then this is true, and this is why. It's based on a theorem or a postulate or a definition. Then if that's true, then this is also true, until you get down to the end, and your last statement is the to prove statement. Now, there are paragraph proofs, but basically you contain the same information. It just isn't set up in the 2-column proof format. So that brings me to the conclusion of the review for this unit. If you still are confused about any of the things that I've discussed, or you feel like you want to see some examples of these, or you just have some questions, general questions before you get started, make sure and let me know. And remember that you need to call me after watching this video to get credit for this assignment. Thank you very much for coming, and good luck on the test.